Right, hello and welcome back to another video. In this one we're going to be starting looking at the math examples, and we've got about 25 different materials here with various different mathematical operations and things that we can use in our materials, and we're just going to go through them sort of one by one and kind of break down exactly what they're doing and how they might be used, and we'll see them in some of the future examples as well, so some of the worked examples. So starting here in the math operations level, and we're looking at the data types here to start with. So we briefly touched on these talking about the node types, but we'll just cover them again. So the different types of data that the engine can use, it makes sense when we're defining certain things to divide them in certain ways. So for example, if we're dealing with UVs, there's two components to that, an X and a Y. So we're going to use a vector 2, or we're going to use data that has two components to it for sort of ease of use. Same if we're dealing with any kind of position, direction, color, etc. There's three components to that. So we have a 3-channel vector, and we're going to have three components there. So it's just combining things together to make them easier to use. So coming in at the top, we have scalars. Scalars are a single value, and this one's been converted to a parameter. So we can either S-click to create a scalar parameter and then give it a name that makes sense, or we can create a constant by 1 and click, and then we can convert it, right click and convert there and convert back. So the difference being, this is a constant. This number is always the same for all materials everywhere in the world. Sometimes we use those, that's fine. This is a parameter, so this can be updated. So we can create an instance and change various values. So you could make a shiny version of something or a not shiny version of it by changing the roughness. This can be controlled by animations, by code, by blueprint, anything like that. So it exposes the values to the sort of the rest of the engine. We'll be using lots of these throughout. I'm a big fan of having lots of parameters. Gives you lots of control and lots of ability to tweak things and make variations. So vector 2, where we're using 2 bits of data at the same time, generally UVs. That's the sort of the most common place where you're using 2 bits of data. Note there's no parameter for vector 2. If I just create another one of these, if I right click and convert, it's going to convert to a vector parameter, and we'll see that later. Vector parameter 4 channels, which is not 2. Interesting, if you convert back to a constant, it converts your vector parameter, which has 4 channels, into a vector 3 parameter. So it goes from 2 to 4 back to 3. So that workflow, maybe not the best, but there we are. Yeah, vector 2 used for UVs. Vector 3 or float 3, again the terminology isn't consistent, is used for color, position, direction, anytime we have 3 items of data at the same time. And if you notice, every object has a location, that's 3 channels of data, rotation, that's 3 channels of data, scale, that's 3 channels of data. It's a 3D world, there's 3 dimensions, so we use 3 channels to define lots of things. Comes up all the time. Another note about sort of terminology, RGB, XYZ, UVW, they're all just interchangeable. The engine doesn't understand that this is R, that's just a label for our benefit. And in fact, sometimes this isn't R, sometimes this is X. And so you just have to kind of remember that these are the same, depending on the kind of space you're working in and what kind of data you're using. They're just numbers to the engine, it doesn't know any better. Moving on, we have vector parameters. So V-click is the shortcut for that. And these are 4-channel parameters. So RGBA in terms of terminology or the labeling, but quite often XYZ or UVW, that kind of thing, depending on what you're doing. Yeah, if your alpha channel is left unused, if you're just dealing with position, that's fine. It's not so wasteful that we're going to worry about it. But yeah. Okay, moving on, we have Boolean parameters, not used so often, but basically work as switches, on or off, yes or no. You can't convert a a value to a boolean like you can in other sort of parts of the engine, and they often come up in some sort of the functions. And so here we have an input where it's asking us, do we want to invert our Fresnel function? And we'll cover this more in later, and that's where a boolean might be useful. So now we have not inverted our Fresnel. Let's preview this. And then if we turn this on, we're going to invert our Fresnel, and now we get the opposite result. Note that using switches can create quite a lot of branches in your material. And so you can have a switch parameter. Here we are. And then this can then be sort of applied per instance, but it's going to be calculating all of this sort of branch as a different permutation. So one branch is going to create 2 materials, 2 branches is 4, 3 branches is 8, and it becomes quite sort of exponential. So can be used and sort of used sparingly, but you can also create quite a lot of shader compile and shader variations by using lots of switches. Switch, static switch. And so this is basically the same setup, using a boolean parameter and a switch parameter, or a switch node rather than a switch parameter. Yeah, we'll cover them and we'll use them when we talk about master materials in the second half of this course. But yeah, just a note to be wary, they can create quite a lot of additional permutations that you don't necessarily need. Last one in terms of material or data types is objects and texture objects and texture samples. So texture objects are actually the data, and this is a reference to a texture on disk. Let's give it a texture. There we are. Let's do these two. Yeah, so this is a reference to the texture on disk. When we're changing textures, when we're using textures, that's what we're getting, is we're getting references to the files that we've imported. But to use them in our materials, we need to convert that texture reference into RGB data or color data or whatever the texture is encoding. So we use a texture sample. Now, for convenience, texture samples don't need to have texture objects plugged into them, but effectively that's what they do. If you mouse over here, it says it defaults to texture if not specified. Well, texture is this setting here inside the node. So for ease of use, we can create texture samples, just T and a click, and then plug in whatever texture we want. If you have a texture selected when you create one, it will default to that. There you are, default texture cube. But we can also just plug in and fill in the value afterwards. And the same, these exist as parameters. So if we want to be able to change our textures in our instance or edit them at runtime, that kind of thing, we can plug that in and use that as a sample parameter. And the same workflow of right click, convert to parameter, and convert to, okay, there doesn't seem to be a convert back from parameter. Well, we can always create a new one. There we go. So samples are outputting color data, red, green, blue. Let's do this. And texture objects are sampling, are referencing the texture on disk. Again, sometimes with textures or with functions. I'm trying to think of one that has it. Excuse me. Quite often with functions we plug in a texture and then sample it inside the function. I'm trying to think which functions do this. Let's find one. I believe this, yes. So this is an inbuilt function for creating movement with textures, and the input for the texture, see it says T2D, that's a texture object reference. So if we bring up here and type in texture, for functions, quite often you plug in a texture object, and then the sampling actually happens inside the function. And you can see here we have texture samples, all referring to that texture object that we've plugged in. and so that's where you'll probably see more of this kind of split between the two things. But when we're making sort of simpler materials, we can just use textual samples. Okay, I think that's enough for an introduction to parameters. In the next video we'll see how we can work with these, kind of split them apart, combine them together, and edit them as we need.